All right, I think we're going to go ahead and get started. And I know that I think some of you might have had some questions over the homework. Is that correct?
Yes.
Okay. All right, so what would you like to discuss? Go ahead.
It was number 62, R.8.
All right, 62.
I got the general idea. I just want to make sure some of the rules.
16 to the negative 3 halves?
No.
No? What number?
62.
On R8, page 79? It's 16 raised to the 3, negative 3 over 2?
67. It's in our, we have the newer books, that's why, I guess.
Do I have the older book?
Yeah, that's the
Is it 19th edition?
Oh, oops.
10.
Oh, okay. Oops, yeah, I have the wrong edition. Okay, well,
I can,
yeah, let me show you. Why do I?
I don't have that one.
Which one do you have?
I have the one.
Bookstore, 10th edition.
In the syllabus? It's 9th?
Oh, I don't know. This is what the bookstore is giving out. It's the 10th edition.
Yeah.
I get a voucher from VA, so I don't really have a choice of what book I get in there. They just write it on a piece of paper, and that's what they give me.
So the syllabus said 9th?
Yes.
Because that's what, that's the official, that's what the department sends out to all faculty. It's like a generic syllabus, and then we add like our names and put our policies. But the book is something we don't control. So
Okay.
I guess what I'll say is, who has the 10th? Who has, holy shit.
I'm telling you,
Who
that's
has
what
the 9th?
bookstore is giving out.
Wait, hold on. Do it again. Who has the 10th edition? And who has the 9th? Oh, shit. Okay, all
Like I
right.
said, this is because I get a voucher or whatever.
Yeah, okay, so these numbers are different, the problems are different? Let me see.
Well, the one that you were talking about, you said that's 67, 16 raised to the 3 second? Or
No, it was
yours
actually-
is 70,
yeah, 70.
16. See, because the 62 I did was this one.
Okay, let me look into this, okay? Let me look into this, because this is going to be an issue. What I'm going to have to do is I'm going to have 2 calendars, one for the people with 10th edition, one for the 9th, so that everyone's doing the same homework problems. Okay? So give me a day or 2 to get that
it was
settled.
probably pretty much the same. Like mine only had one that was different.
Really? Okay. So which problem do you want me to do?
This one right here.
Okay, let me borrow it real quick. So it was square root of x plus h plus square root of x minus h over square root of x plus h and then minus square root of x minus h. All right, that's a good one.
Just a lot of rules to remember.
Yeah, so it says here in the instructions to rationalize the denominator, right? It says rationalize and simplify the expression. So what we're going to want to do, remember rationalizing a denominator, what that means is you're removing square roots from the denominator. And so there's a standard trick that we kind of use for this. Does anybody remember? We're going to multiply it by 1. By 1, but it's a very special one. What is it going to be? It's the, we call it the conjugate. It's what we see here in the denominator, but change the sign of what's in between. That's called the conjugate. So I'm going to go square root of x plus h, but then plus square root of x minus h. And then whatever I do on the bottom, I'm going to do on the top. That way, I can say that that is a 1. Isn't that a 1? Okay. So that's what I'm doing. Sorry, let me turn my phone off. Okay. So the idea here is that when we do this multiplication, the bottom should no longer have square roots in it. So I have to do almost like a foiling on the bottom and a foiling on the top to make this happen. So let's do the, well, you want to do the top or bottom first? I don't really care. You want to do the top? Okay. So when I do it, I'm going to multiply the square root of x plus h times the square root of x plus h. So what happens there? The roots go away, right? And that's because they have the same thing on the bottom, or the radicand, the thing underneath. When you multiply this times itself, it's the same as squaring it, and the square takes care of this. Takes care of the square root, and you get x plus h. All right, so that's the part of the first multiplication. How about the second multiplication? This times this. Yeah, you have this times this, don't you? Since they aren't the same underneath, the radicands are not the same, you cannot do what we just did in the previous one and do this and just kill off the root. So this is what you get. This is it right here. Now you can leave them apart or you can put them together. If you put them together, you'd actually have to multiply the radicands together. That's a minus right there. So you could squeeze them into one root, and then you could actually multiply this out, and if you did that, you would get square root of x squared minus h squared. That's what you would get if you put these two together. All right? So here to here is that line right here. This. So I'm going to put that right here. Plus square root of x squared minus h squared. And then what about this multiplication here in the middle? It's the exact same thing as this, except they're switched, and then they're switched, but everything still works out the same. So you have another one of those, don't you? So you put plus square root x squared minus h squared. And then what's the last multiplication get you? It's this root, same root, so the roots will go away this time, except this time you have x minus h instead of x plus h. Is that clear, everyone?
Yes.
Okay. Let's see. X minus h. So plus x minus h. Now, the bottom, we actually have something that happens here that's a lot nicer. All right? So our first multiplication here to here gives us just x plus h, right? The roots are going to go away again. All right, so here's where things start to get interesting. This root times this root is the same multiplication we did here. So we have plus that root, x squared minus h squared underneath. And now here's where something is going to be good for us. When we do this multiplication here, right, it's the same as this, except it's negative this time, because you have a minus and then a plus. So what you're going to wind up doing is subtracting one of these, and that means it's going to kill it off. And then the last multiplication is this times this. Now we have to be careful here. Since these roots are the same, the root will go away, and you'll have x minus h, right? X minus h. But you're supposed to have a negative, because this is a positive times a negative. So it's minus the x minus h. It means the negative sign must distribute. So it's actually going to be what? Minus x plus h. So just be careful with this piece right here. All right, so let's see where we are. In the numerator, I have x here and x here, so that's two x's. I've done the x's. I have an h here and I have take away h here, so the h's are gone. And then I have this root plus another one, so how many of those do we have? Two of them. So I'm going to say plus 2 of those square roots of x squared minus h squared. That's it up on the top. On the bottom, these went away, right? What else goes away? The x's go away, and all you have is 2h. And now, anything else we can do? They all have a 2, right? Every one of these has a factor of 2 in it. So you could just reduce everything by a factor of 2. So I'm going to just show this. Here's what you're doing. I mean, technically, algebraically, you're actually pulling a 2 out of the top. You're factoring a 2 out. And then you have a 2h on the bottom. So then those 2's go away. So your final result will be x plus square root x squared minus h squared over h. And there's really nothing more we can do with that. But it's rationalized. You no longer have a square root in the denominator. So really, a class like this, what we're trying to get you ready for is to be able to do more complicated algebra like this. Because in calculus, this is what you do. It's a lot of really messy algebra. I always tell my students in calculus, look, the calculus isn't the hard part. It's the algebra that's required to do the calculus. The ideas of calculus aren't that bad. They're kind of out there a little bit, but they're not like, mind-blowing things. It's just what you have to do, manipulating things is tough.
So I guess my original question would have been like the x squared minus h squared. Technically, couldn't you do like a pull out an x and an IH?
No, and here's why, because it's subtraction between the two, not multiplication. So I think what you're saying is if you had something like square root of x squared times negative h squared, something like that. If that were multiplication between the two, you could do the square root of each one, and then you could say, yes, there's an I that comes out. But that's not multiplication. This is subtraction.
Okay.
So you cannot split a root into two pieces if there's addition or subtraction underneath. Okay? All right. So I have a quiz for today, and what I'm going to do is, it's a 2-question quiz, and I'm going to pass it out. And I would like for you to work by yourself, okay? That means I don't want you looking off your neighbors. I know the way you're sitting, it's hard not to just kind of look up and peer over, but look, you either know it or you do not know it, but it's not worth it for you to look off your neighbors, because I consider that cheating, and then cheating means you're dropped from the class and you're given an F, or not drop, I'm sorry, you can't do both. I either drop you or give you an F. But it's not like a little slap on the wrist. It could mean the entire semester is over for you if you're looking off your neighbors. So no single quiz grade is worth that to you. Right? I believe these problems are almost directly out of homework. There are 2 problems, but I'm only going to require you do one. If you do them both, then I'll give you extra credit. All right? So you look at them both, you pick one, all right? But it's timed, all right? You're going to have, I think, I'm going to say 7 minutes, all right? I might up that. I might up that a little bit. Now, look, here's the reason why I'm timing it. You're going to take a test, right? At some point, you're going to take a test. You can look at it. Don't start yet, though. To be fair to everyone, let me pass it out first. You're going to take a test in a few weeks, yes? And you're going to have how long for that test? An hour and 40 minutes, right? Which means you have to be able to do the problems I want you to do in an hour and 40 minutes. So it's not only can you do it, but can you do it efficiently? How long does it take you to do this? And so we need to get an idea of where you are. If it takes you 30 minutes to factor 2 trinomials, we've got problems. All right? Okay, so write all your work on the quiz. Go ahead and start. When you're done, bring it up here. Set it on the corner, and we'll continue. Make sure you just put your name up there. to do one. But you can do the second one for extra credit. You're happy with that? Use a calculator to check your answer. How do you use this calculator? Here's simplify expression. I'm curious to see how you can check it. Got about 2 minutes. Okay, thanks. Appreciate it. Thank you. That's fine. Thank you. 1 minute. Thank you. You done? Thank you. Take it. Sure, that's fine. Okay. Thank you. Well, out of the 10th edition, it was number 62, but in the 9th edition, it's okay. That's time. Please turn in what you have. In the 9th edition, it's 54. Which is that one? That's 9th, I believe. Yeah, 9th edition. So it's number 54. Okay. All right. Please turn in what you have. It's okay. Don't worry about this assignment. I'm going to get it squared away, and I'll send out an email and let y'all know. I'm sure that there's someone has made a calendar for the 10th edition, so I'm just going to send that out, and the problems should match then.
So the one that we have right now, that would be for the 9th, correct?
Yes, it's based on the 9th. Yeah, but don't worry about going back and fixing it. Okay. From here on out, once we start the homework for 1-4. I'll send something out so you know you're getting the right problems. Okay, I'm only going to do the first one here. X squared minus x minus 6 over, x squared minus 5x plus 4. All of this over another fraction, but we wind up flipping that one over and bringing it up here as multiplication. And I believe this is right out of your homework. I forget it's R6. I think it is. Maybe not. I thought it was. R7, okay. That's what I meant, R7. Okay, either way, okay, so you all knew what you were supposed to do, hopefully. You had a complex fraction, you flip the second fraction up and multiply, so that means you have to factor. And so what I'm really checking to see here on this problem is how comfortable are you factoring? And what I would hope is that it does not require any, well, too much work, I guess, for you to get these three factors broken down. This one, and this one, those are all three trinomials. So you do like AC method or guess and check, whatever you've got hardwired in your head. The top left would be what? Minus 3 x plus 2. The bottom, x minus 4, x minus 1. And then top right, x plus 3, x minus 1. And then difference of squares, x plus 2, x minus 2. So that's the way everything factors. And now you should be able to cancel some things. X plus 2's go away. X minus 1 goes away. And then anything else, that's it, right? So on the top, what you're left with is x minus 3 times x plus 3. On the bottom, you're left with x minus 4 and then x minus 2. And you could box this, that would be fine. Or you can multiply everything back out. That's it. So if you can do that problem in 7 minutes, then that's good. If it's taking you longer or you're still having trouble factoring, then I urge you again, you need to go back and work on the factoring because it's a prerequisite. You have to be able to do it in this class. You'll continue to struggle. All right? So just show of hands. How many of you feel like you did okay on this? All right? Good. All right. So we're going to start now. Today is like our first official day of lecture. Although the material we're going to cover may still be stuff you've seen before. All right? But I'm going to try and treat it as if it's kind of new in some sense. All right? Which means we have formal notes, which are located on Canvas for you. And I was asked, do you have to print these out? You do not have to, but I would encourage you to. Your binder that you keep for the class is supposed to have notes in it, and so what I'm looking for there is like handwritten notes. What you're doing in class. What are you writing down when I'm up here? Yes? Yeah, that's fine. Yep. Just as long as you have something nice and organized, that's good with me. Okay, so I'm going to refer to the notes by just kind of looking over there and talking, and then I will go on the board and do my work.
Did you want the notes and the homework separate? Because what I've been doing so far is I've had the notes and then I've been doing the homework as it's been going, so it's all chronological.
As long as it's easy for me to distinguish the two. So like when I get your binder and I check it on that first test, if I'm sitting there and I'm having trouble figuring out where the notes stop and the homework starts, then you can separate them, or you can put little tabs in there. I just need to be able to see where the homework for that section is. Am I answering your question? Yeah. At the top of the page, put homework, and then write the page number or something, at least so I can tell. Remember, the binder is just to keep you organized, all right? I mean, that's all it's about. It's, students who are organized are better students usually than students who just do everything on scratch paper and then throw it away and not care. The more you have everything put together, the easier it'll be for you to review for test, to get ready for test. You can go back and look at everything. It's all in one place. Okay, so 1.4, we're talking about radical equations and equations of quadratic form. So these are special types of equations. When solving an equation, we must first identify the type of equation we're facing. So I put down here, what is that, 6 different types of equations that everyone in this class is going to need to know how to solve. The first one being linear, then quadratic, then radical, then rational, then quadratic form, and then what's called factorable. All right, so these are the types of equations we're going to be working on. The goal in each case is to determine the value or values of the variable which make the equation true. So remember, when you're solving an equation, we're getting solutions. We're getting answers. It's different than an expression. Expressions, you don't get solutions. So here are some preliminary things we need before we can get going with this. These are things you should already be comfortable with. Adding and subtracting like terms. So like if you take this expression here and I ask you to simplify it, you can collect your x squareds together, you can collect your x's together, you can collect your constants together, and get this over here on the right-hand side. So show of hands real quick. How many of you feel like you could combine that together? Yes? Okay. How about when you add and subtract radicals? What is it that you have to be careful with when it comes to radicals and you're trying to add and subtract them? What's inside of the radical has to be exactly the same for you to add them together. So take a look here. We've got square root of 2x plus 1. We cannot add that to square root of x because what's underneath the roots is not the same. But right here, we have another square root of 2x plus 1. And so we can combine this one with this one. And so what we do is we look at the number in front. Now, there is no number in front of this, is there? I mean, not written, but there's really a what? 1. And then there's -5 of these guys. So when you take one of them and take away 5 of them, you should have -4. So that's how we get that right there. And then with the square root x, same thing. We have one of them here. We're going to add 4 of them, so we get a total of 5. So just keep that in mind when you're adding like radicals together. They have to be the same thing under the root. Multiplying radicals, that's kind of like what I just did in the problem on the board to begin class. When you multiply, they don't actually have to be the same underneath. But what you do is, in this case, since they match, you just square the whole thing and it goes away. And also be careful with something like this. If you're going to take an expression like 3 square root of x and square it, don't forget you have to square the 3. Square the 3, get the 9, square the root x, it just becomes x. Remember also the things that you are allowed to do when it comes to an equation. Anytime you have an equation, we look at it like a balance. And so you're allowed to do things to both sides. You can always add the same number to both sides. You can always subtract the same number from both sides. You can multiply or divide anything you want on both sides with the exception of 0. You can't multiply both sides of an equation by 0. It wouldn't make sense. You just kill everything off and then you get 0 equals 0 and it doesn't tell you anything. All right? You can also raise both sides of an equation to the same power. Just remember that if you ever raise both sides of an equation to a power, if the power you raise it to is an even power, you definitely have to check your answers because you introduce the possibility of what are called extraneous solutions. I'll give you a very simple example. All right, so let's say I start with an equation like this. X is -2, right? Now, if I come in here and I square both sides, I square the left side, I get x squared. I square the right side. What's -2 squared? 4, positive 4. All right? Now, let's go and try and get back to our answer. To get back to x, I would have to take the square root on both sides. And when I do that, take the square root of the left side and the square root of the right side. What is it that you always have to remember to put in here when you take the square root on both sides of an equation? Plus or minus. So what you're going to wind up telling me at the end of this is that this side is x and this side is either plus or minus 2. So either positive or -2. So what's happened is, what I'm trying to illustrate is that I'm starting out by telling you x is -2. When you square both sides, you're able to get an answer at the end, but see, you've kind of lost something here. You've thrown in another possibility of x being positive 2, when in fact it was -2 to start. So one of these solutions, x being 2, is what we call extraneous. It would be an extraneous solution. Because we squared it, we kind of created that extraneous solution. The good news is that if there is an answer, if there is a solution, it will be in here. Okay, so it's not like we'll lose the answers, we just might have ones that don't work. Okay? All right. Just keep that in mind when we square both sides, or fourth power, or sixth power, even power, right? All right, you need to know how to factor. Again, going back to this theme since we started, everyone here needs to be strong with factoring. You need to know how to use the quadratic formula. So anytime we see an equation that looks like this, ax squared plus bx plus c equals 0, we need to know that the solutions are this. Right? Sorry, it's so small there. But you've seen that formula before, right? Yeah. Okay, and remember that whenever you do quadratic formula, you usually get two answers, right? Because there's a plus and minus in there. All right, so let's now go and talk through the way that we solve things. And I might do an example to kind of get us going here. A linear equation. Anytime you have a linear equation, the technique for solving a linear equation is to isolate the variable on one side of the equation. So I'll do an example up here on the board of a linear equation. There's a linear equation. What makes it linear? The variable in here is not squared. The variable is to the first power. That makes it linear. And then, of course, it's an equation because we have an equal sign. So the technique is to get the variable by itself on one side of the equation. So you would, let's see, who's feeling good today? Samantha, you feeling good today?
Yeah.
Okay, so what would you do if you were trying to solve this, Samantha? Distribute through. So you're going to free all the parentheses up, right? You're just going to get rid of all of them. So you multiply through, right? Okay, so we get 3x minus 12 plus 5x equals negative 4x minus 4 minus 10, right? And then Nathan says combine like terms on the left side here. And on the right side, that, put the constants together. And then Jalen, what would you do? Curious.
I bring the negative 4x over.
So you're going to move the 4x over here? Okay. And remember with the variable, it doesn't matter which side you go to. You could have subtracted 8x on both sides, but Jalen wants to move it over there. So you're going to add 4x on both sides. So something like this. And you want to take care of this at the same time maybe? So since you want all the variables on one side, anything that's not a variable, you get rid of. So you wind up doing the opposite and bringing the negative 12 over to the right by adding 12 on both sides. So most of us are comfortable with this. I mean, from just looking at you, I can tell I'm boring a lot of you already. But we get what, negative 2 here, negative 2 here. And then last thing, you divide by 12, right? And you got your answer. But see, what we did was we isolated the variable. That's how you solve most linear equations. You isolate the variable. That's very different than the way you solve a quadratic equation. Two different techniques. So what do we do with a quadratic equation? Move all terms to one side. We try and get it to be equal to 0. That's totally different. So let me give you an example of a quadratic. By the way, the answer to this would be negative 1/6. Okay, so if I have something like 3x squared plus x minus 7x equals negative 3x squared plus 4. Okay, so we look at that. Now we have a quadratic equation, right? So you do maybe the same sort of process. You decide, are we okay that it's quadratic? Highest power of x is 2. All right. So we distribute maybe through here again. David, what would you do here? You want to put those together there? And then, Liz, where's your name thing, Liz? No, see, now I know your name. I know your name now, yes. Okay, so Liz, how would you go about this here?
Move the 3x squared over and you cancel out. Or no, you add 3x
So you'd add 3x squared?
and then you move the 4.
You're going to bring, okay, that's what I wanted to make sure everyone saw. What we're doing, this is different than linear equations because what we want to do is we actually want to get everything to one side. That's different. With linear, you're trying to get just the x's on one side and all the numbers on the other, right? Here, we're just going to take everything to that side. So we would add 3x squared. We'd subtract 4. We'd add 3x squared. Uh-oh, subtract 4. Where do I put that? Yeah, I just have to do it out here, something like that. So my next line would look like, how many x squareds would I have? 6x squared. How many x's? Minus 4x, and then minus 4 again, and then equals 0. So remember, you have to maintain the equation, so you have to have equals in there, and then 0 on the other side. And then at this point, you could try to factor it, or you could try to use a quadratic formula. Most likely, I think quadratic formula here, maybe? I don't know. I just made the problem up, so I didn't design it to work nicely. So maybe quadratic formula at this point. So I'm just going to say dot, 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 quadratic formula, dot, 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 we could figure it out. Okay, but the method is different than linear equations. That's what I'm trying to get you to see. All right, any questions? All right, those should be something you've seen. Now we get to the next type of equation, which is a radical equation. These are equations that have roots in them. And the way to do these, again, it is a process. And this you may not be as familiar with. So this one I'm going to go through the, give you an example and go through the whole thing. These can get pretty ugly. So the process says, and we'll read through it first, even though some of it may not make sense. You isolate the most complicated radical first. Isolate means get it by itself on one side of the equation. Then you raise both sides of the equation to the power which eliminates the isolated radical. Repeat that if needed. Solve remaining equation, check your solutions if it was an even power. All right, let's see if we can get our head around that. So I'm going to do a problem out of the textbook, the 9th edition textbook. Let me start with something like, okay, so what if we have cube root 1 minus 2x minus 1 equals 0. So right away, you know that it's a radical equation, right? This doesn't look linear, doesn't look quadratic, it's radical. So the first step is to isolate the most complicated radical. So I have a radical here. That's the only radical I have, so I'm going to isolate it. I need to get that by itself on one side of the equation. So how about we just move the negative 1 over by adding 1 to both sides? Okay, so add 1 to both sides of the equation. Not going to write down plus 1. I think everyone's okay with that. And then at this point, what do I do? Raise both sides of the equation to the power which eliminates the isolated radical. So what power do I need to raise it to kill off a cube root? The third power. The third power. So I'm now going to write here the cube root of 1 minus 2x. But here I come, I'm cubing this side. And then whatever you do to one side, you must do to the other. The effect that you have here is that when I cube the cube root, they go away, right? Because it's this times itself 3 times, and that's the root's gone. And so what you're left with, on the left side, let's see, Elisa? Elisa, right?
Yes.
Elisa, if I cube this left side, what am I going to be left with? 1 minus 2x, okay? And then I won't ask anyone what 1 cubed is, okay? 1 cubed. It's 3. Thank you. Thank you. Appreciate the clarification. And I just subtracted 2 just for the heck of it. All right. So now, what type of equation is this? Linear. It's linear. See, now we've reduced a radical equation to a linear equation. So let's go back through. We raised both sides. We did that. It says repeat if needed, right? Repeat if needed. We didn't need to repeat anything because what we're looking at right now is an equation we know how to solve. It's linear. So it says now solve the remaining equation. So I isolate x now, right? So how about, how do we isolate x? You want to subtract 1 from both sides? So negative 2x equals 0? No. No, this is okay. What do I do to get x by itself here? Divide by negative 2. And so on the left side it goes away. But on the right side, 0 divided by negative 2 is 0, right? You can't divide by 0, but you can have 0 on top. So our solution is 0. Our answer is 0. We can always check our answer by coming back here and checking. If I plug 0 in here for x, I just get 1, right? And the cube root of 1 is 1. And 1 minus 1 is 0. So it does check. Right? That's the most basic radical equation you can get, where you just raise both sides, you get an answer, you're done. Let's go with something more challenging, though. Because these get ugly. I'm going to ask somebody a question here. Just a second. We have a radical equation, right? So since we do, we isolate the radical first. Are we isolated? Do we have an isolated radical right now? Yes? Okay. So then we would raise both sides to a power which eliminates the radical. So what power am I going with? 2. So I'm squaring both sides. Now because I squared, what am I going to have to do at the end of the problem? Because it was an even power I raised it to. I'm going to have to check my answer. All right, so let's now square the left side. I get 12 minus x. And then the right side is just x squared. Do I need to repeat the process? Do I need to repeat? Well, do I have a radical in here? No. Okay, so I can continue on. If I know how to solve this, I can continue. Do you know how to solve this? This is a quadratic equation now, right? So we've turned a radical into a quadratic, and now we just go through the technique. So we want to get everything on one side, don't we? You can bring the x squared over here if you'd like, or you could bring these over here. It's up to you. I'm going to move these to this side, and only because I want to keep the x squared term positive. I prefer to have a positive x squared term. But it's not wrong to bring the x squared over here. So do you agree my next equation would look like this if I moved the stuff on the left to the right? Yes? And do you also agree that when you have an equation, it doesn't matter which way you write it? So we like to always put the 0 on the right. It just looks more familiar to us. Any questions on that? Now this quadratic equation, we can solve it various ways. We could use factoring, if it factors, or we could use a quadratic formula. And remember, the quadratic formula will always work, but it can take a little time. So this is why the factoring is better if it does factor, and this one does, doesn't it? Yes. It's
X plus 4x
plus 4 minus 3. And so your two solutions are negative 4 and positive 3, right? We all good with this? Okay, so remember now we're supposed to check our answers. So where do you check? Back in the original problem. Back all the way to the very top, okay? That's where you have to start. That's where you have to do your checking. So let me check negative 4 first. Let's plug negative 4 in here. What's the square root of 12 minus negative 4? Is that equal to, what are we plugging in for x? Negative 4? Is that true or not? It is not true. Because this side becomes 16, doesn't it? And the square root of 16 is positive 4, not negative 4. So this side's square root of 16. That does not equal negative 4. So that means negative 4 was not a solution. It was an extraneous solution that I accidentally created when I squared both sides. So I chunked this one. And then you check 3. So let's check 3. Does it work? 12 minus 3, is that equal to 3? Square root of 9 equals 3. Check. So this is my only solution. So it may turn out that you get 2 answers and only one works. You may get 2 answers and they both work. You may get 2 answers and neither one works. What would we say if neither one of those worked? You just say no solution. Say no solution. All right. Questions? Comments? Concerns? Gripes? All right, so let's look at another one that's even more challenging. Yeah, how about this? Ooh. All right, square root 2x plus 3 minus 1 minus square root of x plus 1 equals 0. So we have another radical equation, right? So the first step is to isolate the most complicated radical. And so I think this one's up for debate a little bit. How many radicals do we actually have here? We have 2, right? And so we have to choose the more complicated one. And that's what I'm saying. I think we could argue with each other. Some of you may think that's more complicated than this one. It really, you could choose either one, but we try and get the uglier one first. So how many of you think this is the uglier one? Yeah? How many of you think that's uglier? Huh, interesting. Okay, because of the negative maybe? Yeah? Okay. All right, so let's see. If we were to choose this one to be the one isolated, then wouldn't these two go to the other side and become positives? And that's probably good, right? Or you could say, take this negative one and isolate it. So just move that one over, right? And then it would become positive on the other side. So you have to choose which one you want to isolate. You'll get the same answer both ways. But I think this one okay with you, if I isolate this one? All right. So I'm going to isolate the radical on the left, which means I'm going to move these to the other side. I'm actually going to change their order. And that's only because I don't have to do that. I could have the 1 in front, 1 plus the radical. But that's more of the standard way we write it. All right, so I've isolated the radical. And Angie, what now? Angie, right? Oh, no? Who's Angie? Ah, so then I'm going to pick on everyone who doesn't have their name tag. What's your name again? Gia? Gina. Okay, Gina. So we've isolated the radical. So what's the next step, Gina? We're going to square this and this, right? Both sides are going to get squared. Okay, so let me see. If I square this, everyone agree that that's correct?
Yes.
Matthew. All right, Matthew. What about over here?
Square both sides to make it x plus 3. I mean x plus 1 and plus 1.
Okay, yeah, so what's going to happen here when you square this side? This is where things get hard. So think back about something like this. If I give you 4 plus 3, and I tell you to square the whole thing, doesn't that mean you have to do something like that, like square the whole thing? So if you were to square 4, what would you get? If you were to square 3, what would you get? 9. If we add those together, what do you get? 25. But is that correct? No, because what's 4 plus 3? 7. What's 7 squared? 49. That's not 25. Are y'all seeing this? When you square the right side, because it's addition, you square the whole thing, that means you're going to have to FOIL it out. It's not as simple as that goes away and becomes just x plus 1 and then that becomes 1 squared and you add. It's not that simple. So this actually becomes square root of x plus 1 squared around the entire thing. See if you're following what I'm saying here. The left side is okay, right? The left side's just what? 2x plus 3. But the right side is going to be this. I'm going to write it out in detail. That's what it means to square it, right? That's what it means to square it. And that means I get to do a FOIL on that, an expansion. So let me see here. Who am I picking on? Who doesn't have their tag? I ready to go? I think I got everyone, right? Yes? Okay, Daniela, you can go. How about this? All right, there to there, that's our first multiplication. So what are we going to get there? X. Putting you on the spot. So you have the root times the root. They're the same exact things underneath. So that means you're squaring them.
So the square, well, would just be x plus 1.
X plus 1. Yep. So that's this. That's that first multiplication, right? What about the next multiplication, though? Here to here. What's that going to give you? This times 1, right? Which is itself. So you have one of those roots there, don't you? You all see that? And then in the middle, when you do these two, you get another one of those roots. So I get another one of those plus root x plus 1s. And then what about the last multiplication here? Plus 1. That's much more complicated. Matthew, right? That's much more complicated than just having x plus 1 plus 1. So you have to just be ready for that because it's going to get ugly when this happens. So my left side's 2x plus 3. My right side, let me see if I can put anything together. 1 and 1 will be 2. So how about that x that's out here? The 1 plus 1 is 2. And then what's this root plus this root? Lilius? Lilius? How do you say it? Lilius, okay. So it's what? 2 what? 2 square roots of x plus 1. Okay, good. So you're adding the like radicals together. All right, great. We're good. Chris? Repeat it. Repeat the whole process. Because look at your equation now. It's not linear. It's not quadratic. It's actually another radical equation, isn't it?
Yep.
So we're going to repeat the entire process again. And what's the first step? Isolate the radical. So this time we only have one radical. That's good news. We've actually started out with 2 radicals. We've got it down to 1. And now we have to go through the process again. So how about we move the x over and we subtract 2. And so my next line will be, David? Did I already call on you, David?
Yeah.
I did? I'll call again. What do we got?
It's going to be x plus 1.
Okay, equals
Just
2 root x plus 1. Okay, who's my lucky contestant here? Kevin, right? I'll let you catch up. Are you good? I guess one question would be, have we isolated the radical? Yes? What about the 2 in front of it?
You're going to or raise it to the second.
Yeah, my question is, can I leave it here?
Yes.
You can. You can also bring it to the other side, but you'll create a fraction. So you are allowed to leave the 2 here because it's multiplication between these. If it had been 2 plus the root, then of course you would subtract 2 on both sides. So at this point, Kevin, what am I going to do now that I've got the radical isolated? Square both sides. So I square the left side. Now be careful here, square the right side. Oh, I forgot to square. Giovanna, what's the left side? Well, I'll ask Giovanna, what's the right side? The right side's the more interesting one.
Square out what's in the.
Okay, so I'm gonna square 2, so 4.
Yes.
So my right side's going to be 4. And then what about that square root I'm squaring?
It goes away.
It goes away, so I'm left with x plus 1. So I just write this?
No.
No?
You add the plus right in between that.
You need, okay, so what, yeah, this is what I want to make sure everyone's clear on. This is multiplication, right? So you square the 2, you get 4. Times, now you square this, and it goes away, the root goes away, so you have x plus 1. But there's supposed to be multiplication between these. So what am I going to do to be sure that the 4 goes through? You can put it in parentheses. Or you could just write 4x plus 4. But you got to make sure that that 4 affects everything on the right side, or underneath that root. So that's why we have to have the parentheses around that x plus 1. Now the left side, Philip? Are you okay with squaring the left side, Philip? It's all right, Philip.
In my heart, I got it.
Okay. Okay. I don't want you to choke to death in here because I'm asking questions.
He's trying to get out of Where's the x squared plus 1?
Okay, so is it x squared plus 1? So I think what you're doing is you're squaring each one. You got to be careful with that. Remember, with addition, you cannot just apply the squared to both. What do you have to do? Foil it out. You actually have to write on the left side x plus 1 times x plus 1. These are those little things that happen in algebra that you have to be very clear on. That's why we're here, to make sure everyone's on the same page, right? So when you actually do this, you don't get